1.2 Transformations of Linear and Absolute Value Functions. In 1.1, we discussed graphing functions and graphing transformations. So we started with the parent function, then we manipulated it with a transformation, and we graphed to see visually what is happening. Now, we're still working with transformations here, but it is a different concept. Okay, the concept here is that we are going to write rules of transformations. Okay, so this is something we are going to talk about throughout the entire year. Almost every single chapter we come back to write transformations. Okay, so here we go. I am going to go ahead and start. And the first transformation what we're going to talk about is a horizontal transformation, and that is going right or left. This right here, y equals f of the quantity x minus h, is like the key, the absolute key to understanding how to write functions. Alright, so horizontal is always counterintuitive to how it normally seems. Okay, so actually when I have a quantity of like x plus 2, I'm moving 2 to the left. And that's illustrated right here where h is less than 0, meaning a negative. So if h was negative 2 and I plug it in, it'd be like f of x minus negative 2 or x plus 2. So that's going to the left. Now, if h is greater than 0, like a positive number like 3, then I have f of x minus 3, and that's 3 units to the right. Okay, so horizontal transformations, right and left. Alright, always counterintuitive. Vertical transformations are up and down. Here is the basis of this rule, where k is where it's going up or down. You should notice that it is not in the grouping symbol like it is in horizontal. It comes after the fact. Okay? Vertical is always going to sound as it is. Alright, so if k was positive 3, it would really mean 3 units up. If k was negative 5, it would really mean 5 units down. Okay, so what I'm going to do is write the transformation. Okay, so in number 1, I have f of x equals 2x plus 1. That is the initial function that we have. It's not a parent function. It's already been transformed. But what I'm going to do in A is write a new function, g, whose graph is a transformation 3 units down of the graph of f. So now I'm manipulating this already manipulated function. Alright, here we go. A. How I'm going to do that is I'm going to write the new rule for g of x. So g of x is now equal to what? Well, it's equal to f of x, my initial function, and then 3 units down, which is going to come right after the fact. F of x minus 3, just like our vertical transformation, right? F of x plus k. F of x minus 3, 3 units down. Now, all I'm going to do is I'm going to continue to write g of x equals, instead of this time, I am going to replace f of x with my function that I initially started, which f of x is equal to 2x plus 1. So substitute f of x for 2x plus 1 minus 3. Then just continue to combine like terms, and 2x plus, oh shoot, it's negative 2. Or g of x is equal to 2x minus 2. And that is our solution. That is how we write the rule, how we change the function from f of x to now g of x. And it is now changed from f of x plus 1 to f of x minus 2. Alright, I'm going to do the same thing with b. I'm going to take the function h, a new function named h, whose graph is a transformation 2 units left of the graph of f. So I'm still using f of x here. Alright, so b, I'm going to say h of x. I don't want to name it f of x, because I'm changing the function, is equal to what? Well, now what I have is f of x minus h. Well, that's 2 units left, right? So really, that h is negative 2, so it's going to be x plus 2 in my grouping symbol. Okay. Alright, now what I'm going to do is continue to write h of x. And that equals what? Well, I'm going to substitute this f of x in for x plus 2. So watch carefully. Basically, all I'm doing is taking the x plus 2 in parentheses and I'm replacing that with the x. Or vice versa. I'm replacing the x with the x plus 2. So I get 2 x plus 2 plus 1. Alright, now the next step is to simplify the right-hand side. Alright, and now what I need to do here is distribute that 2 in. So I get h of x equals 2x plus 4 plus 1. And now combine 4 and 1, and h of x is equal to 2x plus 5. And voila, I am done. Alright guys, what I'd like you to do is pause the video. Well, first of all, pause the video, try number 2, unpause the video to check your answer. Please go ahead and pause the video now. I'm going to go ahead and flip and show the answer. Alright, there's number 2. A, you should have g of x equals 4x minus 4. B, h of x, you should have 4x minus 13. Okay, the second transformation we were talking about is reflection. And reflection in the x-axis and reflection in the y-axis. I'm going to just go ahead and highlight the x-axis here and the y-axis here. Reflection means we're really just kind of mirroring over that line, or reflecting on that line. And again, the key to writing transformations is this right here. Y equals the opposite of f of x. And what you should notice is that negative sign's out in front. And what's that really telling us is you're going to have to distribute that like 100% of the time. All right? You're always going to need to distribute. I'm going to write that. Okay. Next, over here, reflection in the y of x is y equals f of the opposite of x. And now you can see that's inside the grouping, inside the parentheses. Alright, and that changes things. Okay, you don't need to distribute unless you have something in there you want to factor out, but you're not distributing this point. Okay, so there's the difference. I'm going to go ahead and walk you through a couple of these. Here we go. Concept number 2. A. Write a function g, so g of x, whose reflection is in the x-axis of the graph of f. So really what that means is the opposite of f of x. Alright, so g of x equals the opposite. Now I'm just going to replace f of x with the absolute value of x plus 3 plus 1. Now, as I said before, we are going to distribute 100% of the time here. So I'm going to have to distribute this negative to both terms. It may only be one term, it may be 2 terms, maybe 3 terms, but you're going to have to distribute to each and every term. So when I do that, I get g of x equals the opposite of the absolute value of x plus 3 and then minus 1. And I can't really simplify that anymore, so I am done right there. Voila. B. B is a reflection h of x. The function h of x shows the graph that is a reflection in the y-axis this time. Y-axis. Okay, so now what that means is h of x equals f of the opposite of x. Okay, so now what I need to do, sorry, I want to see. Okay. Now what I want to see is h of x equals, now I'm going to substitute that negative x in for x right here. So it's the absolute value of negative x plus 3 plus 1. Now, in your homework, this may just be the answer. Okay? I'm not quite sure. And when I did it in the book, it was an answer like this where I changed it and I went ahead and simplified farther. So I'm going to do that. So I'm going to show you how to simplify farther, and we'll go from there. So here we go. H of x equals, and now what I can do is basically factor out a negative 1, and I'm left with x minus 3 in that absolute value. So I factored out the negative 1. Then from there, I can basically pull out this negative 1. So h of x equals the absolute value of negative 1 times the absolute value of x minus 3 plus 1. And you may have never seen this before. It's called the product property of absolute values. Okay, and I'm going to go ahead and try to write that in here. Product property of absolute values. Okay, and that's this right here. And what's the absolute value of negative 1? 1, right? So that's 1 times this, and that's just going to be that. So h of x equals the absolute value of x minus 3 plus 1, and we are done. And that is simplified completely. Now, I totally understand that's going to be a little confusing. I do want you to try. I will answer any questions on that. Maybe we'll practice a couple more of those in class. But there is one for you to try. So just use B to walk you through that problem. And what I'm going to do is ask you to try number 4. So pause your work right now, or pause your video now. Give it a try. When you're ready, come on back, and I'm going to show this answer, which I'm going to show right now. Okay, so pause it if you haven't already. Okay, number 4 is g of x equals the opposite of the absolute value of x minus 5 plus 4, and b is h of x equals the absolute value of x plus 5 minus 4. Alright, I'm going to go ahead and pause this video because I'm running out of time.